Ever wonder why the planets orbit the Sun so neatly, like they're in some cosmic gathering? This story will take you on a journey to the early solar system, uncovering the secrets of gravity, speed, and the drama behind orbits that seem calm but are actually full of stories. Imagine throwing a ball super fast sideways. If it's fast enough, the ball will keep floating around the Earth. Well, that concept is similar to what happens to the planets in our solar system. They are trapped in a spinning motion. Planets actually want to fly straight off into space, but there's an invisible rope called gravity. The Sun pulls the planets to keep them close, but their speed prevents them from falling in. The result? An orbit. The Sun's gravity is enormous because its mass is far greater than any planet, so immense that all objects around it get pulled in, including the Earth we live on now. Without gravity, Earth would just float away to who knows where. Imagine you're swinging a rope with a rock tied to the end. As long as you swing it, the rock doesn't fall, but if you stop, it gets pulled straight to the center. Well, the Sun is like the rope holder, and the planets are at the end. Planets can keep orbiting because they have just the right orbital speed. If it were a bit slower, the planet would fall into the Sun. If it were faster, the planet would escape the solar system. So everything has to be perfectly balanced. What's really cool is that each planet has a different orbital speed. Mercury orbits super fast because it's close to the Sun. Meanwhile, Neptune is super chill because it's far away. It's like a motorbike versus a bicycle. An orbit isn't actually a perfect circle. It's elliptical, slightly oval-shaped, so sometimes a planet is closer, sometimes farther from the Sun, but its motion remains stable because the laws of physics are super consistent. A long time ago, millions of years back, the solar system was chaotic. Planets were still scrambling for positions like students looking for a cheap room, but over time, they found their respective orbital paths and finally stabilized. Earth is in just the right spot. Not too close, not too far. That's why our planet's temperature is comfortable enough for water to stay liquid and for life to emerge. If our orbit were just a bit different, we might not exist. If you were on a spaceship and stopped at a certain point, you'd see all the planets moving slowly but surely. They never stop because the laws of nature force them to keep gliding. Interestingly, planetary orbits aren't determined by the Sun alone. The planets also pull on each other slightly. That's why orbits can wobble a tiny bit but remain stable, like friends who influence each other but don't cause major chaos. Jupiter, the gas giant, has the strongest gravitational influence after the Sun. Many asteroids have to obey Jupiter's directions. Jupiter even often acts as Earth's shield from stray rocks. Gravity's strength weakens the farther you go. That's why outer planets like Uranus and Neptune orbit so leisurely. The Sun still pulls them, but not as strongly as it pulls the inner planets. Scientists call this balance between gravitational pull and a planet's speed orbital motion. This law was discovered by Johannes Kepler and further explained by Isaac Newton. In the world of physics, the core of this is simple. A moving object wants to keep moving in a straight line, but gravity forces it to curve bit by bit. The final result? It ends up going in circles. If one day Earth's orbital speed changed, say from a major collision, its orbital evolution could change. That would mess up the climate and life might struggle to survive. But don't worry, such orbital changes are extremely rare. Our solar system has been stable for billions of years, so no need to panic about Earth suddenly going off track. Even so, astronomers keep monitoring all the planets' orbits, because even the slightest shift can provide clues about what's happening out there in space. Planets don't just orbit the Sun, they also spin on their own axis. That creates day and night, so while revolving around the Sun, they're also busy spinning themselves. And at the end of this story, another mystery arises. The planets' orbital journeys actually hold a hidden story about the origin of the solar system. We'll discuss that story now. Ready to continue. Before the planets had neat orbits, everything began with a giant gas cloud called a nebula. This nebula spun slowly, then gradually got faster. This spin energy is the origin of the orbital motion we see today. As the nebula kept condensing, its center became super hot and dense. That was the protosun. The surrounding parts began forming a large disk. From this disk, small bits of matter started sticking together and grew into protoplanets. Because the nebula already had spin from the beginning, all the material within it got carried along in the rotation. That's why the planets all ended up orbiting in the same direction. They just followed the flow from the nebula's initial spin. Imagine spinning donut dough really fast. The center becomes dense, the outer parts spread out. Our solar system formed much like that. This spin is what keeps the planets moving in their paths without stopping. When chunks of rock and ice collided, some shattered, but others stuck together into larger clumps. These collisions made the planets grow quickly, and all the while, they maintained the direction of motion inherited from the nebula. The newly ignited sun gave a big push through light pressure and solar wind. Remaining small dust was blown outward, making the planets' orbits cleaner and more stable. Their paths became even tidier. But not all material became planets. Some became asteroids, comets, or even got destroyed. Some of these remnants got stuck in the asteroid belt or the Kuiper belt. They also orbit the sun, following the same physics laws. The inner planets formed from heavy rock, making them denser. Because they're close to the sun, they move faster. The outer planets formed from gas and ice. They're large, but their paths are long, so their movement is slower. Interestingly, planets kept negotiating positions with each other. Jupiter's pull could shift other objects' paths. Saturn also got involved. All this creates many small, invisible dramas within the orbits. Sometimes planets can experience migration, moving slightly from their original path. This happened billions of years ago when they were scrambling for space. But now their positions are stable, so there's no more major moving around. One of the coolest mysteries. Why can orbits last for billions of years? The answer lies in the perfect balance between gravity and momentum. These two forces lock together, making orbits resistant to change. If the sun's gravity weakened, planets could slowly drift away. But if gravity strengthened, for example, if a lot of matter fell into the sun, planets could move closer. Luckily, such big changes rarely happen. Orbits also have an emotional side if you think about it. Everything runs regularly, stably, and maintains distance, like a healthy relationship, not too close, not too far, but still connected. Earth also has a slight wobble in its orbit. These small changes affect long-term climate, like ice ages. Earth orbits neatly, but it's not that calm if you look over thousands of years. Outer planets like Uranus and Neptune often get disturbances from distant objects at the edge of the solar system. But they remain stable because the vast distance means the incoming pulls aren't too strong. Some scientists believe there's a hidden large planet far out there, Planet 9. If true, it must be exerting a subtle gravitational influence on smaller orbits. This mystery is still being investigated today. Orbits also create seasons. Because Earth is tilted, its journey around the sun causes the parts receiving sunlight to vary. The result? Summer, rain, winter, all are gifts from orbit. If Earth stopped orbiting, we'd fall into the sun within months. If Earth sped up, we could escape into dark space. So our orbital speed is just right, like a factory setting. In the end, planetary orbits show that the universe moves with an elegant rhythm. Everything spins, keeps its distance, and remains in the same harmony for billions of years. And that's the secret of why planets spin around the sun. It all started from a spinning nebula, strict physics laws, and a balance maintained by nature. Pretty awesome, right? And if you like stories like this, or are interested in similar topics, don't forget to subscribe to this channel. By subscribing, you won't miss out on other exciting content. In the next video, there will be an even more interesting topic. It could be more mysterious, more entertaining, or even more surprising than you imagined. Don't forget to turn on the notification bell to stay updated. Likes and comments also help this channel grow. Thanks for watching, and see you in the next video.